Hello, my name is Elliot Paz. I am a teaching assistant at Montana State University Northern. And for today's lecture, we're going over evidence-based public health, chapter 2, out of the book Public Health 101, Improving Community Health by Richard Riegelman and Brenda Kirkwood. And for objectives, we have explained the steps in the evidence-based public health process, describing the public health problem in terms of morbidity and mortality, describing the course of disease in terms of incidence, prevalence, and case fatality, and describing how the distribution of disease may be used to generate hypotheses about cause of disease. We're also describing an approach used in public health to identify a contributory cause of disease or other condition and/or establish the efficacy of an intervention. Identify the types of intervention approaches used when implementing interventions. Describe uses of qualitative data that complement quantitative data. Describing the process of creating evidence-based recommendations. And then finally, we have explaining the role that evaluation plays in establishing effectiveness as part of evidence-based public health, and describing the uses and limitations of predicting population outcomes. All right, so starting up on this, I have figure 2.1, which is the Perry approach, which is a systematic framework for addressing public health issues through evidence-based methods. It consists of 5 basic questions that guide the process. For the first one being of what is the problem. This question helps define the health issues or conditions in the community, identifying its scope, impact, and populations most affected. The next question is what is or are the contributory causes, focusing on the etiology, which is reasons for disability or deaths. This helps identify the root causes or risk factors that contribute to the problem, such as behaviors, environmental factors, or socioeconomic conditions. Third, what works to reduce the health impacts? So here we examine interventions or strategies that have been proven to reduce the health impacts of the problem. May they be public health policies, educational campaigns, or clinical treatments. Fourth, and how do we get the job done? This focuses on the practical aspects of implementing solutions, ensuring that resources are available, stakeholders are engaged, and the strategies are feasible. And then the fifth question is, how well does the intervention work in practice? This involves evaluating the effectiveness of the intervention in real-world conditions, ensuring that the solutions are achieved the desired outcomes, but also looking for any unintended consequences. The reason the Perry approach is circular, as you can see, is that the evaluation process, which is the last question, often reveals new insights or gaps, leading to a continuous cycle of improvement and adaptation. This approach ensures that interventions remain relevant and effective. All right, so now how can we even describe a health problem? Well, the first step in addressing a health problem is to describe the burden, course, and distribution of the disease. First off, for the burden of disease, this refers to how much disability and death a disease causes. We need to assess the current burden and any changes that may have occurred. This involves understanding both morbidity, so frequency of illness or disability, and mortality, which is the frequency of death. We also need to identify whether the burden is increasing or decreasing, and if the disease is impacting certain populations more than others. Then we have the course of disease. Understanding the course involves looking for how frequently the disease occurs, whether it's chronic or acute, and the outcomes, such as recovery, disability, or death. By studying the course, we can make predictions about its progression and impact on individuals and populations. So going more in depth, describing the burden and course of disease typically uses rates. A rate has a numerator, which is your number of events, and a denominator, which is the population at risk. Examples include your incidence rates, which are how many new cases occur over a specific time period, and prevalence rates, which are how many existing cases are given at a specific time. So what we could say, for example, is secondhand smoke causing lung cancer, we would want to test that. Teachers, just for an example, teacher smokes a pack of cigarettes a day, the class is the population at risk, which is your denominator, and the amount of cases of respiratory issues you get is your numerator. Third, then we have describing distribution of disease. So we're focusing on who gets the disease. So age is affecting a specific population in terms of is it the youth or the elderly, gender, men and women, ethnicity, and other demographics. Then when does it occur? Are there seasonal temporal trends? Think of, say, like the flu or the cold. We see those more when they're in the wintertime, for example. And then where does it occur? So geographical locations are areas of higher risk. By identifying these patterns, we can start to form hypotheses about the etiology or cause of the disease, which may lead to more effective prevention and treatment strategies. All right, so now how does understanding the distribution of disease help us generate ideas or the hypotheses about a cause of disease? Well, epidemiologists need to investigate factors like persons, place, and time to find patterns and associations in disease frequency. So starting off with person, this refers to the characteristics of individuals in a population, such as your demographic characteristics, so like age, sex, race, and socioeconomic status, since these all can influence the likelihood of a person getting a particular disease. Then we have behaviors and exposures, so these include factors like smoking, physical activity, exposure to environmental toxins, and medication usage. So, and these behaviors or exposures can increase or even decrease the risk of disease. Then we have place, which usually refers to geographic location, but can also encompass non-physical connections. So we have geography, which is disease prevalence may vary by location, such as a higher rate of respiratory illness in urban areas due to pollution. Then you have non-physical, which are typically your shared environments, such as university communities or online groups, which can also influence disease distribution. Then we have time. Since we also have to consider changes in seasonal and temporal / time changes, we have to say, for example, concerning flu rates are higher in the winter than in the summer. So if we do test and intervention, we need to assess the interventions in the same season, say a flu shot versus the winter and the summer. You also have to consider that each year it has a different strain as well. So these are all factors that you have to consider. All right, so now one thing that has to be noted is, well, how do epidemiologists investigate whether there is another explanation for the difference or changes in the distribution of disease? Well, first off, are the observed differences or changes real or artifactual? And there are three basic reasons. There could be differences or changes in the definition of the disease, differences or changes in the interest in identifying the disease, or three, differences or changes in the ability to identify the disease. So here's some examples. Say we have a new effective treatments for HIV, which have increased the interest in detecting the HIV infection. Here, this creates a bias towards increased reporting and awareness. We also have improved technology that has increased the ability to detect HIV at an earlier point, and there have been numerous modifications to the definitions of HIV/AIDS based on the new opportunistic infections. No, some are basically asymptomatic. Then another example we could say is lung cancer. For this one, say there was a notable rise in deaths in the early data collection. However, what else increased significantly, say between the 1920s and 50s? Population, which means overall deaths and absolute number of people smoking, but also life expectancy. So this increase in lung cancer may have been influenced by all those factors during that time period. So it's a thing you have to keep note of. All right, so for our next topic, we have the implications of a group association. So first off, a group association is a hypothesis about the cause of a disease made without having information on specific individuals within the group. Also note these studies can be called a population comparison or ecological studies. Now note, existence of a group association does not ensure that a cause and effect relationship exists, because we still don't know if the individuals who smoke are the same ones who develop lung cancer. Now note the existence of a group association or even an individual association does not ensure a cause and effect relationship, because they can be misleading if they suggest relationships that do not exist at the individual level. So while they still can be misleading for group associations, epidemiological research looks at these associations at the individual level since they are key to establishing etiology, which is the second component of Perry. So in short, while they may be misleading at first, it still is a way to find the information that we need. All right, now for this bit, we're going to be talking about etiology and establishing contributory cause. First, when we're talking about etiology, we're referring to the cause of disease, which is essential for disease prevention. One thing to note is that the evidence-based public health approach relies on epidemiological research studies to establish contributory cause. This requires going beyond group associations and establishing individual connections between causes and effects. And there are three definitive requirements for a contributory cause. First one, the cause is associated with the effect at the individual level. The cause and effect must occur more frequently in individuals than would be by chance. Excuse me. And secondly, the cause must precede the effect. The potential cause must occur before the effect. Now, say for an example, if we're studying cancer, we also realize, say, those who, just for an example, smoke weed have a high rate of, say, cancer. Maybe you could assume at first that it is the weed that's actually causing the cancer. However, you then realize that a majority of those smokers or of cancer, they're just undergoing chemotherapy. But beforehand, they never smoked. So in that regard, essentially, the marijuana fails being the cause because this came in after the disease started, not beforehand. Then third, we have altering the cause alters the effect. If the potential cause is reduced or eliminated, the effect should also decrease or disappear, logically speaking. Now, for example, is reducing smoking rates. Well, this should lead to fewer cases of lung cancer, for example. And to find these out, we have three different types of investigations that can help us. The first type we have is the case control study, which is useful for establishing the cause that is associated with the effect at the individual level. So most useful for establishing the number one requirement. Then next we have cohort studies. They're best for establishing that the cause precedes the effect by following individuals over time. Say following those who smoke and don't smoke to see who develops the lung cancer. Then you have randomized control trials, which are best for showing that altering the cause will alter the effect by randomly assigning individuals to be exposed or not exposed to the potential cause and tracking the outcomes. This, of course, can lead into ethical considerations. Once strong evidence suggests a potential cause, such as cigarette smoking and lung cancer, RCTs may not be practical or ethical. So in such cases, additional supportive or ancillary criteria are used to strengthen the evidence. All right, so what I have here is a little chart showing the requirements for the contributory causes, and of course how the studies can be used. So for case, it involves comparing people who have the disease with the cases with those who do not, which are typically your controls. The researchers look retrospectively at past exposures or behaviors to determine if there is an association. Then for the next type is cohort. This involves identifying two or more groups or cohorts that differ in their exposure to a risk factor. And then we track the groups over time to see who develops the disease. It also follows the participants into the future, which makes it easier to determine the temporal relationship. The next, of course, we have the randomized control trial, RCT, which its key feature is that it's experimental. The researchers have control over who gets the intervention. But of course, as I mentioned previously, that also raises ethical concerns. So you have to be careful of that. Note the process for establishing contributory cause and efficacy is essentially the same. Efficacy implies that an intervention works to produce the desired effect or outcome.